Okay, so I am going to put a matching section at the beginning of your test. If you look at your notes, the very first page, I mentioned yesterday, or it was either this class or the next class that I mentioned this to, but I am including this as a matching section up here on the first page, where you'll have the name and the function rule, and you'll have to match it to the actual picture of the graph. So the functions that are going to be featured on the matching section will be these first two rows right here. Okay. The reason why I'm not including these right here is because we're going to get to them at a later time. I don't need you guys to memorize them now about how they look. There'll be times where we'll practice graphing all of these, or at least these three in the future. But for now, the matching section of your test is going to mostly focus on these 8 right here. Yeah. For the bottom ones? No, I'm not going to put them. I'm not putting them on the test. Yes, yeah. So for now, we're only going to focus on these first 2 rows right here. Okay. And then you're going to have several different sections. Okay. You'll have one section where you'll determine if a relation represents a function. Then another section where you're solving absolute value equations. Another section where you're looking for equations of linear functions. And here, function transformations like we did yesterday. Okay, so we'll start with this first section right here. Use any method to determine if the following represents a function and explain why. Okay, so there are pretty much 2 ways that you can explain them depending on what the depending on what your relation looks like physically. Here, like for example, these 2 could be answered one way, and then 3 could be answered another way, or the same, or both ways. It's just about knowing how to work each particular one. For this one here, I have these 1, 2, 3, 4, 5 ordered pairs. Okay, and then here I have a function mapping, and then here I have the actual graph of that relation right here. Now, the one thing that we got to keep in mind is the 2 ways that we can tell if a relation represents a function. One is if each x value is mapped to only one y value. Okay? So for example, if I look up here at these 1, 2, 3, 4, 5 points, okay, do each of those points have an x value that's mapped to only one y value? All right, so let's see. I have -9 that's being mapped to -6. I have 3 that's being mapped to -6. Okay, that's still one x value to one y value. Okay, 5 is mapped to 21. 11 is mapped to -2. But here I have 11 also being mapped to 8. So does that make this a function?
No.
No, because this x value is mapped to 2 different places. Right? Now, this is different because 2 x values can share the same y value. But one y value cannot have one x value cannot have 2 y values, right? It's like one person can't be in 2 places at once. But 2 people can be in the same place at once. Right? You see where I'm going with this? So does this represent a function right here? Does number 1 represent a function? No. No. And so there'll pretty much be 2 blanks, right? One will be, does this represent a function? Yes or no? The second blank will be for you to explain why. Okay? So now why does this not represent a function? Now you can be very specific and say that 11 is mapped to 2 different y values, well, actually, that's what we'll go with. So 11 is mapped to 2 y values instead of 1. You could also say not every x value is mapped to one y value. Or you could say 11 is repeated in the domain of this function. Okay, there's a number of ways that you can work around it. Okay, Look at number 2. Look at number 2. I have 3 being mapped to 15, 5 being mapped to -2, 6 being mapped to -6, and 8 being mapped to 21. Does this function map represent a function? Why? Well, hold on. I got a lot of different responses. Go ahead. What were we saying? Okay. All right. John, what were you saying? Okay. What about you, Nate? Okay, all right, yes, good. So all that is right. So yes, so every x value is mapped to only one y value. Okay, good. So yes, this is a function. Every x value is mapped to only one y value. Okay. Look at number 3. I don't have x and y values to look at. I just have the graph of that relation to use. What other way can I use to test if a relation represents a function? Good, the vertical line test. Okay. So does number 3 pass the vertical line test? No. Why? Yeah, because if I draw a vertical line, it passes through more than once. So is this a function? No. Now, why is it not a function? Because it fails the vertical line test. And that's all you have to say for this type of problem. Okay, because that's all you need to say. Okay. Any questions on this section? Does everybody understand how to tell if a relation is a function or not? Okay, we good? All right, then let's move on. Next, we get to solving absolute value equations. Okay, with solving absolute value equations, please pay attention to the directions here. You are going to solve, but you also need to check your answers for any extraneous solutions. Okay? Now, look at number 4. I have the absolute value of 3x plus 4 equals -3. When I look at that problem, what do I know about absolute value? What do we know about absolute value? Right, and so absolute value is the distance. The distance is a measure of the distance from one number to 0 on the number line. And distance is always what? Positive. Distance is always positive. So, is this right here, absolute value of this, ever going to equal a negative number? No. So do I have a solution for this problem? No. Okay? So you may end up with a problem on the test where your answer is that there's no solution. Okay? You have to be careful with what's on the other side of that negative sign. Okay? You have to be careful what's on the other side of that negative sign. Sometimes when you check your answers, you may get one that doesn't fit back into it. That's an extraneous solution. Okay, so you can't use that. So let's say this equation were solvable, and I solve it, and I get 2 solutions. I check my answer, and one of those solutions works, and the other one doesn't. The one that doesn't, I can't include that in my answer because that's extraneous. So I have to use the one that did work, and both sides were equal when I plugged it back in. Okay, so make sure you're checking your answers. Let's look at this one. X plus 4, absolute value of x plus 4, plus 3 equals 17. Okay, first thing I want, if I'm trying to isolate the variable, and the variable's inside the absolute value, then I gotta isolate the absolute value first, which means I'm moving this over right here. Okay, so I'm gonna subtract 3 on both sides. All right, I'm not gonna change this because I'm gonna use this later when I check my work. Okay, so I got absolute value of x plus 4. 17 minus 3 is 14. Okay? Now, when I solve absolute value equations, just because absolute value is always positive doesn't mean that what's inside is always positive, okay? So this x plus 4 can either be equal to 14 or negative 14. Because either way, when I put 14 or negative 14 through that absolute value, I still get positive 14. So I need to split this up to where x plus 4 can either be equal to positive 14 or negative 14. Okay? And then I'm going to solve each one. So subtract 4. So x is equal to 10 here. X is equal to negative 18 here. All right? Now I need to check my work. If I plug 10 or if I plug negative 18 into my original problem and I get 17, then it's good. If I get something else, then it's no good. Okay? So, all right, so I'm going to start with 10. So absolute value of 10 plus 4 plus 3, that's absolute value of 14. Plus 3, absolute value of 14 is 14. 14 plus 3 is 17. So that checks out. Okay, so that's good. Here, I have absolute value negative 18 plus 4 plus 3. So negative 18 plus 4 is negative 14. Absolute value of negative 14 is positive 14. 14 plus 3 is 17. So both of these are my solutions. Okay. Now you're going to see more problems than more different types of problems than these. But again, this is just the most basic way to solve absolute value equations. Make sure you isolate the absolute value first, and then split it up to your inside equals the positive version of what's on that side, and your inside equals your negative version on your other side, right? Another example is, I'm going to use this blank side right here, is if I have x plus 4 in the absolute value equals 17x minus 3. Even something like this, you still have to split it up. X plus 4 equals 17x minus 3, and then x plus 4 equals negative, parentheses, 17x minus 3. Okay, you still have to solve each one. Okay, with this side, make sure you distribute that negative sign. And then, of course, once you solve, make sure you check your answers. Okay, so you may see a problem like this also. Okay. Any questions on this section? Are we clear on how to solve absolute value equations? All right, then let's move on. Next, we're going to find equations of linear functions. There are 3 different forms. What are the 3 forms for linear equations? Standard form, point slope, and slope intercept. Good. Yes. Yes. Okay. So, for each pair of points that we see up here, we're going to write the equation of that line that passes through these points in all 3 forms. So you're going to be writing these in standard form, point slope form, and slope intercept form. Okay. Here's my advice, and I'm going to leave blanks for each form. Okay. I want you to do it in this order to help you out. Start with point slope form. Then go to slope intercept form, and then go to standard form, okay? That's the order that I'm going to put the blanks for these problems on the test. So it would help you to work them out in that order, okay? So for each of these problems, what do I need to find first? The slope, right? Who remembers what the slope formula is? y2 minus y1 over x2 minus x1, okay? So we're going to use that for each of these problems to find the slope first, okay? Again, it doesn't matter which ordered pair are your 1s and which ordered pair are your 2s, okay? If 0 is going to be my x1, then negative 1 has to be my y1. Same thing here. If 3 is my x2, negative 5 has to be my y2, okay? So make sure you whether these are your 1s or these are your 2s, make sure I have a 1 and a 1 and a 2 or a 1 and a 1 and a 2 and a 2. Okay, so please make sure you're not mixing them up. Okay, so let's find the slope for this one. So -5 minus -1 over x2 minus x1. -5 minus -1, so I'm going to add plus a positive. -5 plus 1 is 4. 3 minus 0 is 3. There's my slope. Okay. Now here's the neat thing about this. I do want to start with slope-intercept form. I do want to start with point-slope form, but I have my y-intercept right here. Okay, because the x value is 0. So even when I put it in point-slope form, I can just go straight to my slope-intercept form because -1 is going to be my b. Okay? So for point-slope, remember that's y minus y1 equals m times x minus x1. Okay? So if I plug all those values in using this point, okay, so that's y minus -1 equals 4 over 3 times x minus x1, 0. Okay? And all I have to do from there is just simplify it, okay? So my point slope is going to be y plus 1 equals 4 over 3 x minus 0, okay? If I'm putting it in point slope form, I don't have to go any further than this. What you got?
Oh, wouldn't it be -4 over 3?
Oh, yeah, absolutely. Thank you. Yes, thank you for telling me that. Yeah, because -5 plus 1 is -4, and then I got a positive 3 at the bottom. So exactly. Great. Thank you so much for correcting me. Yes. So there's my point slope form. For my slope intercept. Okay? This one's going to be pretty easy because I have my slope and I have my b right here. So y equals -4 over 3x minus 1. Okay? Now, if I were to go from point slope to slope intercept, I would simplify this, right? So this would be -4 over 3x on this side, and then subtract 1 on both sides, and I'd still get this. Okay, I would still get this. Yes, Nate, what you got?
Why is y1 the intercept?
Because the x value is 0. If I plot that point on the y-axis, that's here. That's what it means for it to be a y-intercept, is where it crosses the y-axis. And any point that's on the y-axis has an x value of 0.
Okay, but if it didn't have a 0,
I could still use the point, but it wouldn't be my y-intercept.
Okay.
I could still use that point, of course, and go from here to here, but it wouldn't, like I said, it wouldn't be my y-intercept. The only reason why I'm able to do this so quickly is because this is my y-intercept. Okay. All right. Then last step is to go to standard form. Now, standard form from slope intercept to standard form is very easy because all I have to do is move this x term over to that side. So here I'm going to add 4 over 3x to both sides. Okay. So my standard form is 4 over 3x plus y equals -1. And there's all three forms here for this problem right here. Okay. So again, if you're going, this is why I suggest doing it in this order, because from this you can easily go to this here, and then from this you can easily go to this by just moving this term over to the other side. Okay. All right. Any questions on this example right here before I move on to the next one? Okay, all right. Same process. I need to find my slope, and I need to put it in point slope form. So here's what I'm going to do. So in the last problem, these were my 1s, these were my 2s. Here, these are going to be my 1s, and these are going to be my 2s. x2 and y2. Okay. All right, so let's find the slope. y2 minus y1, so 11 minus 17, over x2 minus x1, so 7 minus 13. All right, let's simplify that. 11 minus 17, that's -6. 7 minus 13, that's also -6. -6 over itself is +1. Okay. And I can choose any point that I want for slope-intercept form. I just need to choose one. Now that I know what my slope is, I don't need both points. So I'm going to go ahead and use this point right here. Okay. So for my point slope form, I have y minus my y value, so y minus 11 equals m, which is 1, times x minus my x value, which is 7. Now, because my slope is 1, you don't have to put this 1 here. You can definitely leave it off, and it's still correct. But if you want to be precise, go ahead and do that. I'm not going to take any points off. So whether this 1 is here or not, it's not going to bother me whether you put it or not. Okay, but that only works for 1. If it was any other value, you have to put it there. Okay, but because it's 1, it's totally fine if you leave it off there. Okay. All right. So now we're going to go ahead and put it into slope-intercept form. Okay. So for my slope-intercept form, I'm going to do my scratch work on the side here. So y minus 11 equals x minus 7. Okay. So this one's pretty simple. I only need to do one step, and that's to move the 11 over to both sides. Okay. So my slope-intercept is going to be y equals x, negative 7 plus 11 is 4. Okay. And then for my standard form, all I have to do is move that x over. So standard form, negative x plus y equals 4. And there's all three of my forms right here. And I am going to have blanks for each one. So you'll have a place to put your answer. All right. So that way your answer is not embedded somewhere in your scratch work. Okay. Any questions on this section? All right, then let's go ahead and move on to the last one. So the last section is the function transformations that we talked about. Okay? Now, here's the cool thing. If you go back to your matching section, okay, especially if you know that you got your entire matching section right, you can use this to help you in that last section. Okay? But here are your instructions. You're going to get a parent function. Okay? I'm going to ask you to write out its function rule. Okay, or in other words, the expression that represents that function. I'm going to give you a list of transformations, and you're going to apply those transformations to that function, and you're going to graph both functions on the same coordinate plane. Okay? Notice that I said both. Okay? Any list of transformations, whether it's 1, 2, or 3, they should all be applied to the function at the same time. So I should only see two functions in your coordinate grid. This one and this one. Okay? All right, so identify the parent function below and transform the function using the given transformations. Then graph both functions. Okay? So in this example, my parent is the absolute value function. Okay? So if I go to my matching section and I know that I got the absolute value function right, here it is. This is what it should look like. And here's the function rule. Here's the expression that represents that function. All right, so that's what I'm going to put here. Okay? Then when I get to my transformations, I have 3 of them. I have a horizontal shift, I have an x-axis reflection, and I have a vertical shift. Okay? So the way that I usually do it is I try to put it in the order in which it looks on paper when you actually write it out. For example, horizontal shift. Horizontal shift affects just the x values. So that 3 units to the left, that's going to go on the inside. Now keep in mind, this is a horizontal shift. So you have to kind of think opposite. If I'm going to the left, even though it's a negative direction, I'm still going to add 3. Okay? So if I'm going to the left, I add. If I'm going to the right, I subtract. All right? And then I have an x-axis reflection. In x-axis reflection, affects the entire function. It affects the y value. So the negative sign is going to go on the outside of your absolute value. Yes, Nate?
So if it was a y-axis reflection, where would it go in front of the x?
It would go just in front of the x. Okay? Then we're going to take a vertical shift 1 unit down. Vertical shift affects the y values. So I'm going to subtract 1 on the outside here. Okay? There's my function. All right? Now I'm going to go ahead and graph this. So I'm going to make sure to graph both functions here. All right? So if I go to my, and you're going to get a coordinate grid on your test, so you won't have to draw one yourself. Oh, here it is. All right, so I'm going to start by graphing my parent function. I'm going to start by graphing my parent function. And of course, you can use the matching section to help you with your graph. Now, when you're graphing your parent function, I'm not concerned with how precise you are with your graph. Okay, you see how mine's not exactly that precise? All right, your graphs don't have to be perfect. I'm not asking you to find specific points. I'm just asking you to draw the basic graph of your function. Okay? So now I'm going to take that shape. I'm going to go 3 units to the left. So that's 1, 2, 3. So now that the shape is opening up, I'm going to flip it over the x-axis. So now instead it's going to be pointing downward. And when it points downward, I'm going to shift it 1 unit down. So I went 3 to the left, 1 unit down. Now I'm going to graph that part of the function here. And that's all you have to do. Okay? That's all you have to do. All right. Let me go ahead and show you what it actually looks like, just so you can see how similar it is. So I'm going to go over here. All right, so I got absolute value of x. All right, so again, here's the absolute value of x. Oh, x. Yeah, don't worry, I'll clear this out so it doesn't confuse you. And please, when you're graphing your functions, please make sure that I can tell the difference between your two graphs. You can label them. You can use one of them as a dotted line, one as a solid line. You can write one of them in pencil, one of them in ink, or you can use a highlighter, just as long as I'm able to tell the difference between your parent function and your transform function, okay? So, when I do my transformations, again, here's my horizontal shift 3 units to the left. Here's my x-axis reflection. And then I'm going to shift that 1 unit down, minus 1. And then there you go. So again, very similar to what I drew. Your graphs don't have to be as exact. They just have to make sure that the transformations look correct. Okay? Any questions on this last section?